Isotopes. Today we're going to talk about isotopes. Isotopes are atoms of the same element that differ in the number of neutrons in the nucleus. Now we have learned that protons are what makes an element unique. It tells us which is which. And we know that electrons can vary because of their charge, but neutrons can also vary, but they still are the same element. Because isotopes of an element have different numbers of neutrons, they have different mass numbers, and we've been experimenting with looking at different mass numbers. So we're going to start with some simple examples and then move to figure out how we figure out atomic mass on the periodic table. Two isotopes of carbon are carbon-12 and carbon-14. It's asking us to write the symbol for each isotope using subscripts and superscripts, and then determine the number of protons and neutrons and electrons for each isotope. So we have learned to write this notation, C-12 or C-14. We also explored using C12-6 or C14-6, where the top number is the mass number, and the bottom number is the atomic number. And if we were going to count this up, we would have 6 protons, 6 electrons, and 12 minus 6 would give us 6 neutrons. And here we would be looking at 6 protons, 6 electrons, but 14 minus 6 would give us 8 neutrons. So let's try another sample problem. This time we're going to look at oxygen. And there's oxygen 16 and oxygen 18. So again, it wants us to write the symbol for each isotope using subscripts and superscripts, and then determine the number of protons, neutrons, and electrons for each isotope. I suggest that you pause this video right now and try this on your own, and then play it and check your answer. So let's see if you're right. O is oxygen 16, and you would write it as 16, 8, O. And then we have O 18, which we would write as 18, 8, O. I would have, in this case, 8 protons, 8 electrons, and 16 minus 8 would give me 8 neutrons. In this case, I would have 8 protons, I would also have 8 electrons, but 18 minus 8 would give me 10 neutrons. Now, to figure out atomic mass, it's just like figuring out your grades, and we have a weighted average in our chemistry class. So 60% of our grade is tests, 20% labs, 10% homework, and 10% is sort of a do now participation grade. So this is saying if you have a 75% test average, an 80% lab average, 100% homework average, and a 90% do now average, then what is your chemistry average? So to figure this out, we are looking at average is equal to the weight of that area times the grade plus the weight times the grade, and so on. Okay, so in this particular example, we're looking at 0.60, which is our 60% of tests, times our test average of 75, plus the 20% for lab, so 0.20, times our 80 lab average plus the 0.10, which is our 10% for homework, times 100 plus the 10% of due now times that 90 for a grade. If we calculate that, we end up with 45 plus 16 plus 10 plus 9, and our average in chemistry class is an 80 or a B minus. Now, atomic weights work the same way as weighted averages. Scientists figure out how common each element is, how common each isotope is, and take into account the weight of each isotope. So we look to see how much carbon-12 we have versus how much carbon-14, or how much oxygen-16 we have compared to oxygen-18. And the atomic mass is sort of, if I were to take a handful of that element, what would it weigh, if taking into account that some of them will be lighter and weigh 12 and that some of them will be heavier and weigh 14. So if we look at something like bromine, it says 50% of the naturally occurring isotope of bromine have an atomic mass of 78.92, while 49 of the naturally occurring isotope of bromine have an atomic mass of 80.92. Calculate the average atomic mass of bromine, showing all of your work. So the atomic mass is equal to that 50%, 0.5054, times that isotope, which is 78.92, plus the 0.4946 times 80.92, atomic mass is equal to, when I multiply those, I get 39.89 plus 40.02, and therefore my atomic mass is just what I find on the periodic table, 79.91. So there may not be any atom of bromine that weighs 79.91, but the idea being that if I had a handful of bromine atoms, that half of them would be the one isotope and half of them would be the other isotope, so I could find my average atomic mass of 79.91. We're going to illustrate this in class with a lab called Benium.